All right, today we're multiplying monomials. So our objective is to multiply monomials and raise monomials to powers to solve real-world problems. So first we need to talk about what is a monomial. What is a monomial? Mono is Latin for one. So we have one meal, whatever that means. A monomial is a number, a variable, or the product, which is the multiplication of a number, and variables could be more than one, with whole number exponents, meaning you're only multiplying numbers and one or more variables. For example, 6 would be a monomial because it's just a number. X would be a monomial because it's just a variable, so 6 comma x. 5y is a monomial because it's the multiplication, that's a multiply of 5 and y. 6wx is a monomial because it's the multiplication of numbers and variables. 1/3 x to the third is a monomial because it is 1/3 times 3x's times x times x times x, because that's what x to the third means. So it's the multiplication of a number and variables. It is not a division by a variable. So things a monomial is not. For example, it couldn't be 3 times x to the negative 1. Because x to the negative 1 is 1 over x, and that's like a division by x, not a multiplication by x. So that is not a monomial. Another one is having like x to the 1/3. Not a monomial because that's the cube root of x, and you can't have the variable inside a cube root. Now, you can have a root inside like a number inside a root because that's just a number. For example, I can have the square root of 2x, the square root of 2 times x, because the square root of 2 is just a number. It's just a number. It's an irrational number. I can't simplify it any other way, but it's just a number. So I can have the square root of 2 in a variable, but I can't have the x inside the square root because then it's not a monomial because it needs to be the product of that. You also can't have an x and an exponent. For example, let's do that in red. 3 to the x is not a monomial because of this exponent. The exponent is a variable. So it is not a monomial. So all of these guys right here are not monomials. Okay? It has to be a number times one or more variables, or just a variable, or just a number. Okay. We talk about the degree of a monomial. I do my degrees, I explain it slightly differently than the book, but it's kind of the same way. The degree of the monomial is really just the number of variables being multiplied in the monomial. For example, here, if we come up here and we look at these ones up here, the degree on this one, so here, let's go ahead and let's put the degree above. The degree for the 6 is 0 because there are no variables in that. So 6 has a degree of 0 because there are no variables. This next one, x, has a degree of 1 because there's just one single x. This 5y has a degree of 1 because there's just one single y. 6wx. How many variables do we have there? A w and an x, so the degree of that is 2. I'm multiplying 2 variables. This 1/3 x to the third, this one has a degree of 3 because I'm multiplying 3 x's. Okay, so if I have a monomial, let's go ahead, let's get a different one. 16x to the fourth y z to the second. That's a monomial. I'm taking 16 times x to the fourth times y times z to the second. The degree of that, well, here I've got 4 x's, 1, 2, 3, 4. I've got 1 y, and then I've got 2 z's. So 4, 5, 6, 7. So the degree is 7. Okay, that degree is 7. Okay. The way the book explains it is they just look at the exponents and you add them. So like here, on this one here, this x technically has an exponent of 1, so a degree of 1. This y has an exponent of 1, so the degree of 1. Here, w has an x of 1, x has an x of 1, sorry, an exponent of 1. So when I add those up, I have 2. Here, exponent is 3, so degree is 3. Here, when I add these exponents, 4, y to the first, and 1, z to the second, so 4 plus 1 plus 2 gives me that 7. But often I will tell you a very common mistake is to forget that one exponent. So I always like to treat it, it's the number of variables being multiplied in the monomial. And that's much easier to understand in my opinion.